Hello everyone. Thank you for joining in the presentation. In this presentation, I'm going to talk about my recent study of highly dispersed aramid nanofiber in 슈퍼엔지니어링플라스틱, which was done with my great senior colleagues who are mentioned here on the slide. Here, as you can see, here on the diagram, an interactive ANF reinforced PSU nanocomposite was prepared via in situ nucleophilic aromatic substitution polymerization. Using DMSO as a common medium for the fabrication of ANF PSU nanocomposite, the polymerization was smoothly achieved without ANF precipitation and solvent exchange. As a nanofiller, ANF in DMSO was prepared by stirring Kevlar fiber in DMSO containing potassium hydroxide at room temperature for a week. This slide shows physical and morphology properties of the composite. Graph on the left of the stress-strain curves. The blended samples fractured during yielding, while failure of the in situ PSU nanocomposites occurred after a high strain, as in a ductile polymer. Interestingly, the in situ composite exhibited different deformation mechanisms compared to the blended nanocomposite, same to neat PSU. Graph on the right shows morphology of the composite, the images by SEM. In situ and blended PSU composites showed opposite fractured surface morphologies, as you can see in the images on the right on the slide, smooth for the former and rough for the latter. The uneven fracture of blend sample comes from a complicated failure mode, with a mixture of the elastic and plastic deformed polymers. In contrast, in situ sample showed a relatively even fracture as images. Additionally, the in situ composite evolved nanoscale voids that act like stamp perforations to cut the specimen clearly in case of failure. This slide is to investigate further evidence for enhanced mechanical properties of the in situ ANF PSU composite. A higher filler content of ANF PSU composite was prepared by in situ or blend method to confirm the ANF grafting on the polymer chain. This investigation was confirmed by FTIR and SEM analysis. As you can see, the FTIR spectra, amide I band of ANF was observed in the blend sample spectrum, but in the in situ sample spectrum amide I band intensity was negligible. Even after in situ sample was washed with chloroform to remove physically bound PSU, most FTIR bands of in situ sample correspond to fingerprints for the PSU spectrum. Add to this, the characteristic amide I, 2, and 3 bands from ANF were more clearly observed than before washing. Differently, the spectrum of washed blend sample was identical to that of pristine ANF, suggesting that the PSU chains only physically interacted with ANF. Lastly, the ANF grafting of the PSU was clearly demonstrated by the SEM images here. After a single washing, the fibrous ANF structure was evidently observed in blend sample, while the ANFs was surrounded by polymer chains in situ sample. The multi-washed blend sample showed the same morphology of ANF as the sample washed once, while the multi-washed in situ sample showed nanoscale PSU beads on the ANF surface. These all show polymer beads that are physically inseparable, are closely related to the covalent grafting. The chemical grafting reactions during in situ polymerization distorted the fibrous ANF structure. Here, this is the brief summary and conclusion of the presentation. If you have further questions, you can leave them on Q&A on Macaro 2020 website. If not, thank you all for your time.